There is a sentence that sounds like pure philosophy until physics starts agreeing with it. Time may not be what it seems. That is not the same as saying clocks are fake. It is not the same as saying change is fake. It is not the same as saying your childhood, your grief, your aging face in the mirror, and the fact that tomorrow has not happened yet are all meaningless hallucinations. The claim is stranger than that, and in some ways more dangerous. Because what modern physics keeps doing, again and again, is removing from time the exact features human beings trust most. A universal now. A single shared flow. A master clock built into the cosmos. An obvious direction written into the laws themselves. A clean distinction between the past that is gone and the future that does not yet exist. One by one, those comforts have been weakened. Relativity tells us there is no global present sweeping across the universe like a cosmic spotlight. Quantum theory complicates the role of measurement and the status of temporal order in ways that are still debated. Thermodynamics suggests the arrow of time may come not from the deepest equations, but from special large-scale conditions. In some of the most serious frontier attempts to unite gravity and quantum mechanics, time does not even appear in the most familiar way at the fundamental level. That is where the unease begins. Because if time is less a river and more a bookkeeping of change, then the universe may not move through time the way minds move through experience. The present may be less a global feature of reality than a feature of perspective. And the thing we call the flow of time may not be a basic ingredient of the cosmos, but an emergent pattern arising from memory, entropy, causality, and the local structure of observers like us. That does not make time irrelevant. It may make it more intimate. More local. More conditional. More psychological. More deeply tied to the way information is arranged than to any cosmic current carrying existence forward. And that possibility should bother you. Because if time is not fundamental in the way it feels, then almost every human intuition about reality has been built on a distortion so useful we mistook it for a fact of nature. We plan. We regret. We wait. We count birthdays. We bury the dead. We say time passed, time was wasted, time heals, time runs out. But what if the universe does not contain the kind of flowing time those sentences assume? What if the deepest description of reality contains change, relation, probability, geometry, and structure, but not a single cosmic, now, marching forward? What if the greatest illusion in physics is not matter, not solidity, not emptiness, but the feeling that the whole universe is moving with us from one moment to the next? Tonight, we are going to move carefully through that possibility. Not recklessly. Not mystically. Not by pretending physics has proven that time is unreal. It has not. But physics has made ordinary time much harder to trust. And by the end of this documentary, the strangest thing may not be that time exists. It may be how little of what you mean by time survives contact with the laws of the universe. Human beings do not merely live in time. We live by it. Time organizes hunger, sleep, deadlines, memory, promise, fear, and hope. It is the invisible scaffold around which the whole architecture of ordinary life is built. Even when we are not explicitly thinking about it, we are obeying it. We age inside it. We imagine futures inside it. We interpret causes and consequences through it. We endure pain by reminding ourselves that it will end. We treasure beauty partly because it will not stay. So when physics begins destabilizing time, it is not destabilizing a technical variable. It is reaching into the center of experience. That is why this subject feels bigger than equations. Not because equations are unimportant, but because time is one of the few places where physics and intimacy overlap completely. You do not have to be a cosmologist to know what it feels like to be carried by an unseen order you cannot stop. A child knows waiting. A patient knows duration. A grieving person knows the impossible. Asymmetry of before and after. A parent can watch time become visible in the face of another human being. A dying person knows what it means for time to stop being abstract. And yet physics, especially in the last 100 years, has repeatedly warned us that the time we feel is not the time reality most fundamentally requires. In Newtonian physics, time was majestic and clean. It passed uniformly everywhere, independent of observers, independent of motion, independent of gravity. There was one universal stage and one universal clock. Different people could disagree about where objects were, but they all lived inside the same shared temporal river. Relativity destroyed that comfort. Einstein showed that duration depends on motion, gravity, and reference frame. Simultaneity is not universal. There is no single cosmic now that every observer shares. Clocks do not reveal a hidden master rhythm, they participate in a world where time itself is locally shaped by structure and motion. Then thermodynamics complicated the story further. The fundamental equations of many physical processes do not clearly contain the strong one-way direction we feel in ordinary life. Yet the world we actually inhabit is full of irreversible processes. Glasses shatter. Heat spreads. Memory points backward, not forward. Eggs scramble. Stars burn fuel and do not unburn it. The arrow of time seems undeniable in experience, but physics keeps forcing us to ask whether that arrow comes from fundamental law or from statistical conditions. Quantum theory then adds its own unease. In some formulations, time enters conventionally. In others, it becomes slippery. The equations evolve cleanly, yet measurement and observation raise questions about why the world appears to produce definite histories. Some quantum processes are time reversal invariant in ways everyday life certainly is not. The deeper you go, the less obvious it becomes that the passage of time is a basic ingredient rather than an emergent appearance. And in the search for quantum gravity, the problem becomes even more radical. Some of our best attempts to describe the universe at its deepest level, or at least some of our most important clues, suggest that time as an external parameter may not be fundamental at all. In the Wheeler-DeWitt equation, for example, the universe in a certain formal sense appears timeless. Whatever that ultimately means, and physicists debate that fiercely, it is enough to show how deep the problem goes. The trouble is no longer that time behaves strangely. The trouble is that we do not yet know whether time belongs in the basement of reality or only in the higher floors. That is the journey of this documentary. We are going to begin with the time you feel you know best, the obvious human flow from past to future. Then we will watch that certainty break apart. We will see why universal now died with relativity, why clocks disagree without malfunctioning, why entropy gives time a direction that the deepest equations may not obviously contain, why memory makes the past feel special, why causality is asymmetrical in some ways and not others, why quantum theory both preserves and destabilizes temporal intuitions, why some physicists think time may be emergent, why gravity makes the issue worse, and why even the word illusion must be handled with care. Because if time is an illusion, it is not the kind that means fake. It would mean something more precise and more unsettling. It would mean that flow, now, and passage may be higher-level features of reality, real at the level we inhabit, indispensable for the kinds of beings we are, but not fundamental in the deepest physical sense. Like temperature. Like solidity. Like the smooth surface of water when looked at from far enough away. Not unreal. Emergent. And emergence is not a downgrade. It is a warning that reality may not be organized according to The categories that feel most natural to consciousness. So before we get lost in spacetime, entropy, and quantum gravity, let us start where all the confusion starts. With the time we think we know. The ordinary human experience of time is so persuasive that it can be hard to notice it is an interpretation at all. Time feels like a flow. It feels as though the universe is arriving. One moment becomes the next. The future turns into the present and then falls backward into the past. We do not merely think this. We live as if it were the most obvious feature of reality. Every calendar, promise, memory, and fear quietly assumes it. There is a deep reason for that. Human consciousness is not a neutral recorder. It is a machine built to organize changing information into a usable world. We do not perceive all possible correlations at once. We track events in sequence. We store records of some states and not others. We anticipate. We compare. We update. We are stitched together by memory, not by omniscience. That structure makes time feel directional long before physics ever enters the room. You remember yesterday and not tomorrow. You can alter what happens next, at least locally, but not what has already occurred. Causes seem to point one way. Explanations run from prior conditions to later outcomes. The living body itself reinforces the asymmetry. Wounds heal in one direction. Children become adults, not the reverse. Hunger returns. Fatigue accumulates. Seasons circle, but we do not circle back into the same age. So the first great fact about time is not physical, but phenomenological. Time feels real because experience is asymmetrical. The second fact is linguistic. Language quietly hardens this asymmetry into metaphysics. We speak of time passing, time moving, time running out, time carrying us, time healing, time taking, time giving. These are metaphors, but they do not feel like metaphors. They feel like descriptions because they align with the lived architecture of consciousness. Then culture reinforces the illusion of obviousness. History is a sequence. Music unfolds. Stories have beginnings, middles, and ends. Rituals recur, but always against the background of aging. Clocks tick. Sundials sweep. Shadows move. The heart beats. Everything around us conspires to teach a simple lesson: time is a universal container in which events happen one after another. This is a useful lesson. It is also, according to modern physics, not fundamental. And the problem begins with a question that sounds childish until you think about it honestly. What exactly is flowing? If time passes, relative to what does it pass? If the present moves, through what larger temporal medium does it move? If the universe is progressing from one moment to the next, where physically is the process by which all of reality updates itself? The ordinary answer is usually no answer at all, because common sense does not ask the question. The flow of time feels primitive enough to be self-explanatory. We rarely inspect the concept, because it is the background against which inspection occurs. But physics is merciless toward background assumptions. Once the question is asked cleanly, ordinary time starts to look less like a substance and more like an organizational habit. We label some configurations earlier and others later. We compare records and changes. We build clocks that exploit regular processes, the swing of a pendulum, the vibration of cesium atoms, the orbit of Earth. But none of that proves the existence of a cosmic river. It proves only that some processes are regular enough to be used as standards for change. And that distinction is subtle enough to miss for centuries. A clock does not reveal time as an invisible fluid. A clock correlates one change with another. The hands move because gears move because springs unwind or electricity oscillates or atoms transition. We then compare those changes with other changes, the rise of the sun, the aging of a body, the duration of a chemical reaction, the interval between heartbeats. This is already a hint that time may be less a thing than a system of relations among changing states. But before we go too far in that direction, we need to understand the precise moment when physics first shattered the ordinary picture. Because the most intuitive feature of everyday time is not just flow. It is sharedness. You and I may disagree about taste, politics, or memory, but surely we live in the same now. Relativity says otherwise. If you had asked a scientist before Einstein whether two distant events could be absolutely simultaneous, the answer would likely have seemed obvious. Of course they could. The universe, on the old picture, contained one common time. Different observers might measure positions differently if they were moving, but the temporal order of events, and the global meaning of, at the same moment, was assumed to be objective and universal. Einstein broke that. Special relativity begins with a deceptively simple demand: the laws of physics should look the same in all inertial frames, and the speed of light in vacuum should be the same for all such observers. That combination seems almost innocent until you work through what it forces reality to give up. What it gives up is universal simultaneity. To see why, imagine two lightning strikes hitting opposite ends of a moving train. An observer standing on the embankment may judge the strikes simultaneous because the light from both reaches them at the same time and because they are centered between the strike points in their own frame. But an observer on the moving train, traveling toward one flash and away from the other, may receive the signals at different times and, once the geometry is correctly analyzed, conclude that the strikes were not simultaneous at all. This is not a trick of delayed perception. It is not merely that the second observer learns about the events differently. The theory says simultaneity itself is frame-dependent. There is no deeper hidden fact about which distant events are really happening now independent of a chosen frame. That is one of the hardest truths in physics to emotionally accept because it violates something older than science. It violates the intuition that the world comes with one shared present. Human beings do not naturally feel frame-dependent. Consciousness arrives locally and confidently. Whatever else is confused, the sense of now seems immediate. But relativity reveals that this immediacy cannot be promoted to a global property of the universe. The present at your location is not something physics can extend across cosmic distances in one observer-independent way. This changes everything. It means there is no universal slice of the universe labeled the present moment that all observers agree on. Reality is not built out of cosmic snapshots laid down in one absolute order. Instead, time and space are woven together into a structure in which temporal separation depends on motion and frame. This is not speculation. It is established physics. GPS satellites must account for relativistic effects, or their timing errors would accumulate disastrously. Particle accelerators, cosmic ray muons, and precision experiments all confirm that the Newtonian picture of shared absolute time is gone. What died with Einstein was not time itself. What died was common time. This has philosophical consequences that are difficult to overstate. If the universe does not contain one globally privileged present, then our ordinary talk about what is happening right now in a distant galaxy becomes frame-loaded. There can still be events there. Still be causal relations, still be histories. But the idea that there is one master now sweeping Equally across Andromeda, Earth, and a quasar at the edge of the visible universe is not part of fundamental physics. And this, in turn, destabilizes the flow picture. Because if there is no single global present, what exactly would be flowing? A moving present cannot be a universal physical feature if there is no universal present to move. The sensation of passage must then come, if it comes at all, from something more local, perspectival, or emergent than the naive picture suggests. This is often the first major disorientation people feel when they seriously engage with modern time. Not that time behaves strangely. That, now, might not be a feature of the universe in the way it feels like a feature of experience. Of course, relativity does not force everyone into one philosophical interpretation. Some physicists and philosophers accept a block universe picture, others resist it or modify it. Some look for ways to rescue becoming in a relativistic world. Some distinguish local proper time from global simultaneity in ways they think preserve more than critics allow. But one fact stands firm. The universe does not supply one universal now. And once that is gone, time becomes less like a shared stage and more like a structure of relations between observers, events, and paths through spacetime. This is the point where many people instinctively retreat. Surely, they think, even if simultaneity is weird at large distances, at least time itself still flows 1 second at a time for everyone in principle. It does not. Relativity goes further. Different observers do not merely disagree about simultaneity. They age differently. Nothing exposes the strangeness of time more ruthlessly than a good clock. Clocks are supposed to settle arguments. They are the instruments we build precisely so that time can stop being vague. If two people disagree about duration, we consult the clock. If a machine fails, we timestamp it. If an experiment depends on precision, we refine the oscillator. A clock, in everyday life, feels like the material ally of common time. Relativity turns it into evidence against that assumption. Time dilation means that the amount of elapsed time between events depends on the path taken through spacetime. Two observers who separate and reunite can disagree about how much time passed for them, and neither clock is broken. There is no hidden, correct, time behind the disagreement. Their experienced durations are both physically real. This is not a metaphor. It is one of the most experimentally verified results in modern science. Muons created high in Earth's atmosphere survive longer on their journey to the ground than Newtonian intuition would suggest, precisely because of relativistic effects. Highly accurate. Atomic clocks flown on airplanes or placed at different gravitational potentials diverge as relativity predicts. Satellites in orbit must account for both special and general relativistic time shifts. If they did not, navigation systems would fail spectacularly. The world does not contain one master stopwatch. Instead, each clock measures proper time along its own path. That phrase matters, along its own path. The universe is not a single river of time in which all objects drift equally. Different world lines through spacetime accumulate different amounts of duration. Motion matters. Gravity matters. Geometry matters. Time is not a universal background. It is a participant in structure. This realization is often introduced through the so-called twin paradox. One twin travels at relativistic speed and returns younger than the twin who stayed on Earth. The scenario sounds paradoxical only if we cling to the idea of shared time. Once acceleration and world line differences are properly included, the asymmetry is consistent and measurable. The traveling twin really ages less. That sentence is so simple it can mask its philosophical violence. Really ages less. Not seems younger. Not appears younger from some optical illusion. Less proper time has elapsed along that path. So the question changes from, what time is it, to something more physical and less comforting. What duration has this system accumulated along its trajectory? This is a far colder universe than the one of common sense. In everyday thought, time is a container holding all events. In relativity, time behaves more like geometry. It is not something everything shares equally. It is something paths negotiate differently. And gravity deepens the shock. General relativity tells us that mass energy curves spacetime. Clocks deeper in a gravitational well run differently from clocks farther out. Time near a planet's surface does not pass at the same rate as time farther from the mass. Near black holes, the divergence becomes extreme. The stronger the gravitational field, the more time participates in curvature. This is why the phrase, the flow of time, becomes increasingly suspicious the more physics you know. Flows do not usually fork according to motion and gravitational potential. A river does not pass differently for two observers simply because one changed velocity and the other climbed a mountain. But duration in the universe does exactly that. What we call time, then, is already beginning to fracture into a more subtle picture. There is local experienced duration. There are coordinate times chosen for convenience in particular descriptions. There is proper time along world lines. There is no single universal metronome underwriting all of it. And once we accept that, another thought becomes hard to resist. Maybe time is not the stage. Maybe spacetime is. Maybe the universe is not a story being written line by line into a moving present, but a larger, four-dimensional structure in which the distinction between past, present, and future is not written into the world as sharply as human intuition insists. This is the temptation of the block universe. And whether or not we ultimately endorse it, we have to look at it directly. Once relativity kills universal simultaneity, a new picture starts to feel almost unavoidable. Instead of imagining the universe as a three-dimensional space evolving through a single global time, we imagine a four-dimensional spacetime in which events occupy locations not just in space, but in time, and the whole structure exists as a single geometric entity. This is the intuition behind the block universe. In its strongest form, the block universe picture suggests that past, present, and future are all equally part of reality. The universe is not becoming one moment at a time, rather, the full spacetime manifold simply is. Your birth, this sentence, tomorrow's sunrise, and the death of a distant star are all events located in the block. What differs is not their degree of existence, but your relation to them as a temporally embedded observer. This idea can sound absurdly abstract until you realize how naturally it grows out of relativity. If different observers carve spacetime into space now and time later differently, then privileging one set of slices as the actual present begins to look arbitrary. The geometry itself does not come labeled with a universal moving now. That label appears to be something observers impose. Hermann Minkowski, who recast Einstein's relativity in the language of spacetime geometry, put it in a form that still sounds unsettling today: space by itself and time by itself are doomed to fade away, and only a kind of union of the two retains independent reality. This is the moment where many people first feel that time might be an illusion. If all events in spacetime simply exist, then what becomes of passage? What becomes of the felt movement from one moment to the next? Is it merely something consciousness experiences while occupying different locations along a world line inside a fixed block? The block universe is powerful partly because it makes sense of relativity cleanly. It treats Spacetime as a whole and does not try to smuggle back a universal present the theory never gives us. It also explains why the laws can be written in ways that are global and geometrical rather than river-like. But we should be careful. The block universe is not an experimentally separate fact on the same level as time dilation or relativity of simultaneity. It is a serious interpretation of what relativity seems to imply. Many physicists are comfortable with it. Others resist its metaphysical conclusions or think it overstates what the mathematics requires. Some seek views in which becoming is local, emergent, or compatible with relativity in subtler ways. Still, even the resistance tells us something important. Ordinary flow is no longer safe. Whether you fully endorse eternalism, the philosophical name often given to the block universe view, or not, physics has already forced a severe conclusion. The universe does not obviously contain a universal present becoming real one layer at a time. That picture is not in the equations in any simple, fundamental way. Now, this can sound emotionally devastating. If the future already exists, in some sense, what happens to freedom, novelty, or the openness of life? What happens to loss, if the past is somehow still there in the block? What happens to the urgency of becoming? These are real philosophical problems, and we will return to them. But notice the key issue for our documentary. The block universe intuition makes time less like flow and more like structure. That is the recurring inversion. What feels dynamic may be geometric. What feels like passage may be perspective. What feels like universal becoming may be local consciousness encountering ordered records along a world line. And if that is even partly right, then the ordinary human sense of time moving is not a basic fact about the universe. It is something produced within the universe by beings with memory, causality, and limited access to information. Of course, there is a major objection. The world does feel directional. Eggs break and do not unbreak. People remember the past and not the future. Stars burn fuel and age. Entropy increases. Even if the deep geometry is block-like, there is clearly an arrow in the world we inhabit. That arrow is not abolished by relativity. But its source may be stranger than a fundamental flowing time. To understand where direction comes from, we have to leave geometry for a while and enter thermodynamics. If relativity undermines the idea of a universal now, thermodynamics destabilizes another comforting intuition. That the direction of time is simply built into the deepest laws. Because in many fundamental equations, time does not appear with the same stark one-way preference that experience insists on. Run the microscopic laws backward, and in many cases they still make sense. The equations are often reversible or nearly so in structure. Yet the world we inhabit is drenched in irreversibility. Ice melts. Perfume diffuses. A glass shatters. Smoke spreads. Stars exhaust fuel. Bodies decay. Memories accumulate of what was, not what will be. Where does that asymmetry come from? The classic answer is entropy. Entropy is one of the most misunderstood words in science because it has been turned into a metaphor for everything from laziness to moral decline. In physics, it is more precise. Very roughly, entropy measures how many microscopic arrangements correspond to a given macroscopic state. High-entropy states are overwhelmingly more numerous and statistically typical than low-entropy ones. Systems evolve from special, ordered, low-entropy configurations toward more generic, less constrained ones because there are vastly more ways to be disordered than ordered. This is not a moral law. It is a counting law. That is why I like the motif that time may be less a river than a bookkeeping of change. Thermodynamics is almost literally bookkeeping. It tracks what kinds of macroscopic histories are statistically natural given the microscopic possibilities. When you see cream mix into coffee, you are not watching time itself push the cream forward. You are watching a system move from a highly special state, separate regions of cream and coffee, toward far more numerous mixed states. The reason the process looks one way is not that the deepest laws scream forward. It is that the reverse would require an absurdly special arrangement of microscopic conditions. And this insight is devastating, because it suggests that the arrow of time may not be fundamental law after all. It may be emergent from statistics plus very special boundary conditions. In other words, the universe looks temporally directed not because time itself comes with an intrinsic arrow everywhere and always, but because the universe began in an extraordinarily low entropy state compared with what was possible. The reason the future tends to look more disordered than the past is that we are living downstream from a very special beginning. That is one of the most profound and unsettling facts in modern physics. The felt direction of time, one of the most immediate features of human life, may depend on the universe having started in a condition of extraordinary order. Why did it start that way? That is not a solved problem. It is one of the deepest open questions in physics and cosmology. Roger Penrose and others have emphasized just how special the early universe appears to have been from the standpoint of gravitational entropy. The puzzle is not only why the universe was hot and dense. It is why it was so ordered in precisely the right way for entropy to have room to increase. This matters because if the arrow of time depends on special initial conditions, then the direction we experience is contingent, not inevitable. Time's asymmetry is not merely a local, obvious property. It is tied to cosmology. That is a staggering inversion. You crack an egg in a kitchen, and the deepest explanation reaches all the way back to the structure of the early universe. But entropy alone does not yet explain the intimacy of temporal experience. It tells us why many processes are irreversible and why records accumulate one way rather than another. It does not by itself explain why memory points to the past, why explanation feels asymmetric, or why the present feels like a moving edge. To understand that, we need to talk about records. Because a world with an arrow is one thing. A mind that knows which way the arrow points is another. There is a simple reason the past feels different from the future. The present contains records of the past. That sentence sounds almost trivial until you realize how much it explains. Memories are records. Photographs are records. Fossils are records. Crater fields are records. Scars are records. Ash is a record of burning. Light arriving from a distant galaxy is a record of what that galaxy was doing long ago. The world is full of traces. And traces point one way. You have memories of breakfast and no memories of tomorrow's lunch. A shattered glass on the floor contains information about a more ordered prior state. The intact glass does not contain information about a future scattering of shards. We find records downstream from low entropy states because record making is itself a physical process that increases entropy overall. This is one of the key ways thermodynamics enters consciousness. The asymmetry of memory is not some separate mystical feature of mind. Minds are physical systems that generate and store records. Record formation depends on irreversible processes. That ties psychological time to thermodynamic time. You remember the past not because the past has a metaphysical glow and the future does not, but because the present is full of physical correlations produced by earlier states. The future, from your local perspective, is not yet correlated with your memory system in that way. It has not left records in you because, causally and thermodynamically, those interactions have not occurred. This also helps explain why the past feels fixed while the future feels open. The past is recorded. The future is underdetermined relative to the records you currently possess. Of course, whether the future is metaphysically open is a further philosophical issue. But at the level of lived experience, openness is a function of information. You have partial knowledge of what comes next and extensive physical records of what came before. That informational asymmetry becomes emotional asymmetry. So when people say time flows from past to future, what they are often reporting is something subtler. Records accumulate asymmetrically, and consciousness rides on records. This is why some physicists and philosophers think the sensation of passage may be deeply tied to memory architecture rather than to a global moving present. The mind is constantly updating its internal state, preserving correlations with earlier conditions and using them to model possible later conditions. The result feels like movement through time. But perhaps what is really moving is not the universe. Perhaps it is the information state of the observer. That is a radical thought, but a disciplined one. It does not deny change. It relocates the source of temporal experience. The universe may not move through time the way minds move through experience. The flow may be what it feels like for a record-making system to continuously reconfigure itself while embedded in a thermodynamically asymmetric world. Notice how far we have come from common sense. Ordinary intuition says the future becomes the present and then falls into the past. Physics increasingly suggests something like this instead. Physical systems create records in one entropic direction, observers are record-rich systems, and the resulting architecture makes temporal asymmetry feel like a moving now. That does not make the feeling fake. It makes it emergent. A rainbow is not fake because it depends on perspective. A temperature is not fake because it emerges from molecular motion. Likewise, the felt distinction between remembered past and unremembered future may be real at the level of observers without corresponding to a fundamental global flow in the underlying laws. This also reveals why the word illusion must be used carefully. If time's flow is an illusion, it is not an illusion in the sense of a mistake with no physical basis. It is more like the apparent solidity of matter. Real at one level, misleading if mistaken for the deepest level. Still, memory does not explain everything. We also explain the world asymmetrically. We think causes come before effects. We understand the past as generating the future, not the reverse. We do not simply remember asymmetrically. We reason asymmetrically. So now we have to ask whether causality itself carries a direction, or whether that too is partly emergent. Of all the things time seems to govern, causality may be the hardest to surrender. It is one thing to hear that simultaneity is frame-dependent. That already feels strange, but it can remain abstract. It is another to hear that the arrow of time may be statistical. That is disorienting, but still intellectually tractable. Causality goes deeper. We experience the world as a machine of before and after. The match lights the paper. The push moves the door. The impact breaks the glass. Explanations run from earlier conditions to later ones. So naturally that we rarely stop to ask whether the direction belongs to causality itself or to how beings like us reconstruct events from records. Physics gives a mixed answer. Relativity imposes causal structure through light cones. Some events can influence others, some cannot. This much is objective and powerful. There are limits on signal propagation and orderings of events that all observers must respect if one could causally affect the other. In that sense, causality survives relativity robustly. But even here, the notion of cause is more subtle than common sense suggests. The fundamental equations often do not explicitly say cause. They describe lawful relations. We interpret those relations causally because we are embedded agents who intervene locally and possess information asymmetrically. Then thermodynamics arrives again. Why do causes feel like they come before effects? Partly because we infer causes from records, and records point toward lower entropy pasts. We can manipulate local systems and watch predictable consequences unfold into a future that is informationally unresolved. We cannot perform analogous interventions on the past because the records and correlations are already fixed relative to us. So part of temporal asymmetry in explanation may come from our condition as thermodynamic observers rather than from the deepest structure of law. This does not mean causality is unreal. It means causal language may be a high-level way of organizing lawful dependence in a world with entropy, records, and limited observers. The distinction is subtle but important. A fundamental equation need not contain, because, for there to be reliable asymmetries in how explanation works for embedded creatures. Quantum mechanics complicates the matter further. Entangled systems challenge naive locality. Some interpretations and formal tools even allow us to treat temporal order in less classical ways. There are research programs exploring indefinite causal order in specialized quantum settings, where the order of operations is not fixed in the usual sense. These are frontier issues and must not be exaggerated into the claim that ordinary cause and effect have evaporated from daily life. They have not. But they do show that the clean classical picture of a single universal order of causes and effects is not fundamental beyond question. Then there is the philosophical temptation to reverse the whole structure. If the block universe is right, does cause merely mean one event stands in the right relation to another inside the block rather than literally generating it? Do we say the past causes the future only because that is the direction in which records and interventions make sense for us? Some physicists and philosophers are comfortable with such deflation. Others think causation retains a real directional role even if the laws are time-symmetric. The debate is not closed. What matters for us is the pattern. The more deeply physics looks, the less obvious it becomes that temporal asymmetry is written straightforwardly into the basement of reality. Instead, asymmetry may emerge from geometry, entropy, boundary conditions, and the local standpoint of agents. Again, this is not nihilism. It is reclassification. Time may not be the engine of causality. Time, or at least the ordinary direction we associate with it, may itself be one expression of a deeper asymmetry in records, entropy, and physically permitted interventions. That is a severe conceptual shift, because it means the universe may not come pre-labeled with the explanatory arrow we feel in life. The arrow may be what explanation looks like from inside a low-entropy, record-rich, local perspective. And if that is true, then quantum mechanics becomes even more important. Because the quantum world is where many of our everyday assumptions about sequence, definiteness, and observation begin to fray. So now we descend into the layer of physics that both preserves and threatens temporal intuition at the same time. Quantum mechanics is famous for making matter strange. What is less widely appreciated is how strange it makes time. At first glance, the standard formalism seems friendly enough. The Schrödinger equation evolves a quantum state through time in a precise mathematical way. Time appears as a parameter. The system changes. The story marches on. So perhaps quantum mechanics leaves the basic picture of Time untouched while merely making particles weird. That comforting thought does not survive long. For one thing, much of the underlying quantum dynamics is time-symmetric in a way ordinary experience is not. If you reverse time in many quantum equations, they remain structurally valid. Yet measurements, decoherence, definite outcomes, and the world of records all seem to happen irreversibly. That tension is not trivial. It is one version of the quantum measurement problem. The basic dynamical evolution is elegant and reversible, but the world we experience contains definite outcomes and irreversible-looking records. Where, exactly, does the asymmetry enter? Different interpretations answer differently. In some views, the wave function never collapses and the appearance of definite outcomes arises through branching, decoherence, and observer-relative experience. In others, collapse is real and introduces genuine irreversibility. Hidden variable approaches, objective collapse models, and relational interpretations all handle the temporal story differently. There is no universally agreed philosophical resolution. What matters for this documentary is not choosing a winner. It is noticing the pattern. Quantum theory makes temporal common sense unstable. Even the role of observation can be misleadingly described if we are careless. Popular science often says observation creates reality, which is far too vague. What matters physically is interaction, entanglement, decoherence, record formation, and the conditions under which definite classical-like outcomes become available to observers. These processes are temporal, but their relation to deep time symmetry is subtle. Then there is entanglement. Two systems can be correlated in ways that resist naive classical separation. This does not allow usable signals backward in time or faster than light in the ordinary sense, but it does undermine the comforting idea that reality is built out of self-contained local pieces evolving independently. Temporal narratives become harder to keep simple in a universe where the state of the whole can be prior, in an explanatory sense, to the state of the parts. Some frontier work goes even further, exploring whether temporal order itself might be indefinite in specially engineered quantum processes. In such cases, one cannot always say operation A happened before operation B in the classical sense. Again, this is not a claim about your morning commute or the history of civilizations. It is a technical clue that the conceptual furniture of time may not be fundamental in every regime. And then there is a more haunting idea: perhaps time and quantum theory are entangled. Conceptually, because the emergence of a classical temporal world depends on decoherence and records. The universe at its most fundamental scale may not contain the familiar sequence of definite events we later project back onto it. That thought reaches toward quantum cosmology, where the problem becomes acute. If the universe as a whole is a quantum system, what external time is it evolving in? Outside the universe, there is no obvious master clock. This is one reason the problem of time becomes so severe in attempts to marry quantum theory with gravity. The very framework that treats time as a background parameter begins to wobble when the background itself becomes dynamical. So quantum mechanics does not simply say time is unreal. It says something more destabilizing: many of the structures by which we experience temporal order may arise only at certain scales, under certain conditions, and through certain forms of interaction. Beneath that, the world may be described in ways that are less committed to the ordinary flow we feel. This is where the motif returns with full force. The universe may not move through time the way minds move through experience. Quantum mechanics does not conclusively prove that. But it keeps making the alternative harder to avoid. Which brings us to another crucial reversal. What if clocks do not measure a substance called time at all? What if they merely measure change against change? A clock is one of the most ordinary objects in the world. That is why it is so dangerous. Ordinary things are the things we trust not to lie. A clock on the wall, a pulse in the wrist, the orbit of Earth, the oscillation of a cesium atom, these feel like neutral witnesses to time itself. They seem to reveal an invisible quantity flowing steadily beneath events. But physically, a clock is not a detector of a cosmic fluid. It is a system undergoing regular change. A pendulum swings. A quartz crystal vibrates. An atom transitions. A planet orbits. An electrical circuit oscillates. We choose some process because it is stable and repeatable, then compare other processes to it. The measurement of time is the comparison of change in one system to change in another. This sounds almost too simple, but it matters enormously. Because it removes the need to imagine time as a separate substance. What clocks directly give us is not access to a hidden river. They give us correlations among physical processes. This way of thinking has a long history, and it becomes especially important in relational and background-independent approaches to physics. If the deepest laws do not require a global time parameter in the naive sense, then what observers actually do is track relations, this subsystem changed while that subsystem changed by a certain amount. In everyday life, that is exactly what we do without noticing. We say a meeting lasted an hour because the clock hands moved a certain way while the meeting unfolded. We say a person waited years because bodily change, planetary motion, and record systems all remained correlated. We never actually perceive pure time separate from change. We perceive changing systems and infer duration from regularity. This is why some philosophers and physicists have suggested that time may emerge from relations among changing quantities rather than existing as a fundamental independent backdrop. Again, be careful. This does not prove that time is unreal. It shows that operationally, physically, what we call time is always accessed through change. No one has ever scooped a sample of time from the universe the way one draws water from a well. We infer time by comparing processes. That point becomes especially sharp in cosmology and quantum gravity. If the universe as a whole is all there is, what could an external universal clock even mean? There is nothing outside the totality to time it against. The most physically meaningful notion may therefore be internal change. The configuration of one part of the universe relative to another. This is another place where the phrase, time may be less a river than a bookkeeping of change, becomes exact rather than poetic. A good part of what physics does is keep track of how observables vary relative to chosen standards. The standards feel like time because they are regular. But the regularity belongs to physical processes, not obviously to a metaphysical stream flowing beneath them. This also helps explain why different clocks can legitimately disagree in relativity. If clocks were mere windows onto one underlying universal flow, disagreement would look like malfunction. But if clocks are world-line-dependent physical processes measuring proper time through different geometries, then disagreement is not scandalous. It is what the world requires. And this leads to a profound discipline of thought. Whenever you are tempted to say, time passed, ask what physically changed. Whenever you imagine time flowing, ask what process you are tracking. Whenever you assume a universal clock, ask where in the laws such a thing actually appears. Often the answer will be humbling. What appears instead is structure, relation, geometry, entropy, interaction, and change. Time is still there in the theories, but increasingly as a relational or formal quantity rather than as the vivid global flow of common sense. The greatest challenge to this way of thinking comes from cosmology. Because if time's arrow depends on low entropy and clocks are only change comparers, then the early universe suddenly becomes the key to everything. Not just to galaxies and expansion, but to why time feels one way at all. If you want to understand why time points in one direction for us, you eventually have to ask why the universe was born into conditions that made such a direction possible. This is where cosmology becomes unavoidable. We have already seen that entropy gives time its practical arrow and that records, memory, and irreversible processes ride on that arrow. But entropy could not increase the way it does unless the universe began in a very special state. The early universe was hot and dense, yes, but also ordered in a surprisingly particular way. At first this sounds backwards. How can something so hot and dense count as ordered? The answer lies partly in gravity. For non-gravitating systems, equilibrium often looks uniform. Spread things out evenly and entropy is high. But with gravity, clumping matters. A smooth early universe with matter distributed with extraordinary uniformity represents low gravitational entropy relative to the highly structured, collapsed possibilities available later: stars, galaxies, black holes, clusters. Gravity gives the universe room to become more disordered through structure formation, collapse, and thermodynamic evolution. That means the arrow of time we experience in kitchens, brains, and galaxies is tied to a cosmological fact: the universe began in a state special enough to allow entropy to rise. This is astonishing. The reason you remember the past and not the future is connected, ultimately, to the large-scale state of the early cosmos. It is difficult to exaggerate how radical that is. The arrow of time does not appear to be a merely local feature of ordinary physics. It is cosmological. It depends on boundary conditions of the universe as a whole. And here the mystery deepens, because physics has not yet fully explained why the early universe had this special low-entropy structure. Inflation explains some things powerfully, including the large-scale smoothness and flatness of the universe, but it does not simply dissolve every question about the low-entropy beginning. Why the universe began in a state from which temporal asymmetry could emerge remains among the deepest unsolved issues in theoretical physics. This is where gravity makes time especially difficult. In general relativity, gravity is geometry. Spacetime is dynamical, not a static background. In cosmology, the large-scale evolution of the universe is itself a change in the stage on which all local processes unfold. But if the stage changes, and if the arrow depends on global boundary conditions, then time stops being a local obviousness and becomes a question about the whole architecture of reality. At the same time, general relativity complicates time through gravitational time dilation, black holes, horizons, and singular structure. Clocks in different gravitational environments measure different proper times. Near horizons, temporal description becomes highly observer-dependent. In the early universe, where quantum gravity likely matters, the very notion of a classical spacetime background may fail. So gravity does two things at once. It helps explain why the universe had room for time's arrow through cosmic structure and low initial gravitational entropy. And it threatens the naive meaning of time by making the spacetime background itself dynamic and, at extremes, unstable as a classical concept. That combination is why time becomes such a serious problem at the intersection of gravity and quantum theory. The old Newtonian comfort, one time for everything, is gone. What replaces it is not yet a complete final picture. Still, one thing is clear: the arrow of time is not simply a local law stamped into every process from below. It appears connected to the history of the universe from above. And that makes the present even more suspect. Because if time's direction depends on local records and global conditions, then perhaps the present itself is not a thing the universe has in common, but a thing observers construct from where they stand. So now we ask the question that haunts every conversation about time. What is now? The present feels like the most certain thing in existence. You can doubt memory. You can doubt prediction. You can doubt interpretation. But the feeling of now, the sense that this moment is vividly, unquestionably present, seems prior to argument. It is the condition under which arguments happen. That is exactly why physics makes it so hard. Relativity has already stripped us of universal simultaneity. There is no single global now sweeping across the cosmos. So whatever the present is, it cannot be a universal physical sheet laid over all events. What, then, is left? One possibility is that the present is local. An event can be present to an observer in the sense that it lies at the observer's current point on a world line, tied to the immediate structure of perception, memory integration, and bodily process. On this view, now is real but not global. It belongs to situated observers, not to the universe as a whole. Another possibility is more austere. The present may not be a fundamental feature of reality at all, but a perspectival effect generated by conscious systems updating information in real time, or what we call real time. The brain integrates sensory inputs, constructs a temporally extended specious present, and experiences itself at the edge of known records and unknown outcomes. The sharpness of now would then be a feature of information processing, not a global physical property. This idea often provokes resistance because it can sound like the present is being demoted to mere subjectivity. But that is too dismissive. Perspective is not trivial. Color depends on visual systems and wavelengths, yet color is not meaningless. Temperature emerges from underlying motion and yet is physically indispensable at the scales we inhabit. Likewise, the present may be local and perspectival without being fake. Still, the demotion is real in one sense. The universe does not appear to privilege your now in the way experience does. That is a hard sentence to metabolize. Because the psychological present feels central. It feels like the blade that divides what exists from what no longer does and what has not yet arrived. But physics increasingly suggests that this blade is not part of the universe at large. It is part of the way certain subsystems, minds, inhabit and process a structured world. This also helps explain why the present has fuzzy edges in neuroscience and psychology. Human awareness does not sample a perfect mathematical instant. It integrates over brief windows. There is lag, synthesis, reconstruction. The present of experience is already not a knife edge, it is a constructed interval organized for usefulness. So even at the level of consciousness, now is less pure than it feels. Physics then compounds the point by showing that no observer-independent now exists globally. The combination is brutal to common sense. The present turns out to be neither metaphysically universal nor psychologically instantaneous in the naive way. And yet, again, we should avoid exaggeration. Physics has not proven that becoming is unreal in every conceivable sense. Some philosophers and physicists defend views in which temporal becoming is local, emergent, or still physically meaningful. But the burden of proof has shifted. The obviousness of now no longer counts as evidence of fundamental status. This is one of the great humiliations modern physics inflicts on intuition. The thing that feels most immediate may be least global. And once we accept that, the frontier becomes even more radical. Because if time's arrow depends on cosmology, if the present is perspectival, if clocks measure relations among changes, and if relativity denies a universal now, then perhaps time itself is not in the basement of reality at all. Perhaps it appears only when the universe is described in a certain way. That possibility lives in some of the deepest and most dangerous territory in modern theoretical physics. There is a point in the story of physics where time becomes not just strange, but optional. That point lies near the attempt to reconcile general relativity with quantum mechanics. The trouble begins with a mismatch of frameworks. In ordinary quantum theory, time often appears as an external parameter. The system evolves with respect to time. In general relativity, by contrast, spacetime is dynamical. Geometry is not a fixed background. It responds to matter and energy. So when you try to quantize gravity or describe the universe as a whole quantum mechanically, a severe question appears. Time with respect to what? There is no obvious external clock outside the universe. There is no fixed background stage guaranteed by general relativity. This helps generate the infamous problem of time in quantum gravity. One of the most famous expressions of this problem appears in the Wheeler-DeWitt equation. In simplified terms, when the universe is treated in a canonical quantum gravity framework, the fundamental equation can appear not to contain time in the usual way at all. The universal wave function seems, formally, static. No explicit time parameter marches it forward as in the familiar Schrödinger picture. This has inspired a range of interpretations, some sober, some reckless. The reckless versions say, physics has proved time does not exist. That is not a responsible conclusion. The sober versions say something more nuanced. Our usual notion of time may not be fundamental in a complete quantum gravitational description. Time may emerge only in approximate, internal, relational, or semi-classical regimes. That is still astonishing enough. It means the universe, at its deepest level, might be described without the thing our experience treats as the most unavoidable fact. How could time emerge from timelessness? Different approaches suggest different answers. In some relational views, one physical quantity can serve as an internal clock relative to others. In semi-classical regimes, approximate time can emerge when the geometry behaves classically enough for other subsystems to evolve relative to it. In some ideas inspired by thermodynamics, information theory, or holography, temporal order may arise alongside classical spacetime itself. None of this is settled. But the field is unified by a common intuition: the time of experience and everyday physics may not be the deepest layer. This is where care matters most. Frontier physics can easily become a magnet for mystical overstatement. So let us separate what is exciting from what is established. Established, there is a real and serious problem of time when trying to unify quantum theory and general relativity. The familiar roles these theories give time do not sit together cleanly. Not established, a final, universally accepted solution in which time is definitively absent. Emergent, or replaced by something else. Still, the conceptual pressure is already enough to disturb common sense profoundly. Because even if timeless formulations are only part of the correct story, they tell us the following. Reality may be describable at a deep level without referencing a universal flowing parameter corresponding to ordinary time. The temporal world could be a higher-level appearance, not the primitive substrate. That would place time in the same strange family as temperature, fluidity, and solidity. All are real. All are indispensable in the regimes we inhabit. Yet none is fundamental in the most microscopic description. They are emergent orderings of deeper degrees of freedom. If time belongs to that family, then illusion becomes a dangerous but defensible word. Not illusion as in falsehood. Illusion as in mistaking the effective for the fundamental. You see a wave moving across the ocean. The motion is real, but the wave is not a self-contained object over and above the water. You feel the earth as still beneath your feet. The stability is real. Enough for life, but not fundamental to the larger dynamics. Likewise, the passage of time could be real for beings like us while not being written into the basement equations as an irreducible cosmic flow. This is one of the most unsettling ideas physics has ever entertained. Not because it abolishes life as we know it. Because it suggests that the thing we trust most may be a local way reality becomes legible to minds. And when a subject reaches that point, one discipline becomes morally necessary. We must stop and separate what the science firmly says from what interpretation adds and what speculation still risks overstating. This documentary has spent a long time making time feel unsafe. Now we owe it precision. Because there is a difference between what physics has established, what it strongly suggests, and what remains interpretive or speculative. Without that distinction, the subject collapses into either dogma or mysticism, and both are betrayals. So let us cleanly separate the layers. What is established? Relativity has destroyed the Newtonian notion of absolute universal time. There is no single observer-independent simultaneity spanning the universe. Duration depends on motion and gravity. Time dilation is real. Proper time along world lines is physically measurable. The thermodynamic arrow of time is real in the world we inhabit. Entropy increases in closed systems statistically, and irreversible processes dominate macroscopic life. The past is record-rich. In ways the future is not. The universe appears to have begun in a very special low-entropy state relative to the possibilities available, though the full explanation of that fact remains open. Clocks measure physical processes. They compare change with change. They do not reveal a universal cosmic metronome in the old Newtonian sense. These are not philosophical preferences. They are hard-won parts of modern physics. What is strongly suggested, but interpretive? The block universe is a serious interpretation of relativity, but not itself a distinct experimental result. Many physicists and philosophers find it compelling, others resist its metaphysical strength. Or seek alternatives. The idea that the felt flow of time may be emergent from memory, entropy, and information processing is powerful and increasingly plausible, but it is not a closed theorem. It is a synthesis of physics, philosophy, and cognitive structure. The claim that the present is perspectival or local rather than globally physical is strongly suggested by relativity and neuroscience-friendly considerations, but the exact metaphysical status of now remains debated. The idea that causal asymmetry is partly emergent from thermodynamic and informational asymmetry is also powerful but not universally interpreted in the same way. What remains frontier and speculative? A final quantum theory of gravity in which time is definitively absent at the deepest level. A universally accepted interpretation of Wheeler-DeWitt-style timelessness. A full derivation of classical time, temporal flow, and experience becoming from deeper timeless or relational structures. The claim that time is completely unreal in the strongest possible sense. These remain unsettled. This distinction matters because the title of this documentary could easily be abused. Time is an illusion is the kind of phrase that can be made to sound smarter than it is. Used carelessly, it flattens the real achievement of modern physics into a slogan. A better formulation is harder and more honest. Physics has shown that ordinary time is less universal, less fundamental, and less intuitive than human experience suggests. That is already enough. Enough to unsettle. Enough to reframe. Enough to make the universe feel less stage-like and more relational. Enough to tell us that human temporal experience is not a transparent window onto fundamental structure. If we go beyond that, we must go carefully. Because there is a moral difference between saying, physics has challenged the common picture of time, and saying, science has proved that nothing ever happens. The first is profound and responsible. The second is usually performance. Still, once the clean distinctions are made, the strange core remains. We do not return to ordinary time uninjured. We do not get to go back to the old comfort that the universe comes with: one clock, one now, one flow, one obvious distinction between what has happened and what is becoming real. That comfort is gone. And once it is gone, a new question becomes unavoidable. Why, if physics keeps stripping time of these features, does the human mind need them so badly? Suppose, for the sake of argument, that the deepest physical description of reality contains no universal now, no global passage, and perhaps not even fundamental time in the way common sense imagines. Why does human consciousness cling so fiercely to the opposite? Because flow is not a luxury for a creature like us. It is a survival architecture. A living organism must distinguish what can still be influenced from what can only be recorded. It must preserve some traces of earlier states and use them to model likely later states. It must coordinate action in sequences, not in totalities. It must simplify, compress, prioritize, choose. It must move through the world as though there is a next step, because biologically and cognitively, there is no other workable way to inhabit local reality. So flow may be less a metaphysical revelation than a mode of operation. The present matters because action is local. The future matters because uncertainty matters. The past matters because records matter. A mind that did not organize the world temporally would not be a mind like ours at all. That is why temporal experience feels so basic. It is not arbitrary. It is the shape intelligence takes when embedded in an entropic universe with partial information. You do not need the universe to possess a global moving now for a brain to need one operationally. This is analogous to other evolved simplifications. The world does not contain colored surfaces in the naive sense, it contains wavelengths, reflectance profiles, and visual systems. Yet color is indispensable for organisms like us. We do not perceive all microscopic motion in matter, we perceive solidity, texture, and weight. Those experiences are not false in the practical sense. They are effective interfaces. Perhaps flow is an interface too. Not a lie. Not a hallucination. A useful organization. This helps explain why the denial of ordinary time can feel almost offensive. It sounds as though physics is attacking the most intimate structure of existence. But perhaps it is doing something subtler. It is not saying your experience is worthless. It is saying your experience was never meant to be a fundamental ontology. Consciousness is not a microscope for the deepest layer of law. It is an adaptation for navigating local conditions. And those local conditions contain change, entropy, records, decisions, bodily aging, and incomplete information. Under such conditions, temporal flow is not a mistake. It is an extraordinarily effective summary. Still, summary comes at a price. Summaries feel obvious until a deeper theory reveals what they left out. The map looks like the territory until satellite imagery humiliates it. A flat horizon looks like the shape of Earth until curvature wins. The sun looks like it moves around Earth until a larger geometry makes sense of the appearances. Likewise, time feels like a flowing universal medium until relativity, thermodynamics, quantum theory, and cosmology expose the layers underneath. The human mind does not like this because it wants reality to meet experience halfway. We want the world to be, at its deepest level, at least somewhat like it feels from the inside. Physics is under no obligation to preserve that. And maybe that is the lesson. The need for flow does not prove flow is fundamental. It proves only that beings like us require temporal organization to be the kinds of beings we are. Which is already poignant enough. Because it suggests that passage may belong to consciousness the way horizons belong to perspective, not arbitrary, not fake, but local and conditional. And once you accept that, the ground begins to shift not just scientifically, but psychologically. Because a universe without fundamental flow is not merely a technical correction. It is a challenge to identity itself. A universe with less fundamental time is harder to live in than a universe with strange particles. You can accept quarks and never feel personally threatened. You can accept dark matter and still love your morning coffee. Even black holes, for all their conceptual violence, remain mostly distant objects. Time is different. Time enters every grief, every plan, every regret, every sentence that begins with someday or back then or too late. So when physics unsettles time, it unsettles the grammar of the self. Because identity depends on sequence. You are not merely a collection of states. You are a continuity interpreted across memory and anticipation. Your sense of being someone comes from the felt relation between what has happened, what is happening, and what might happen next. Remove ordinary temporal intuition. And personhood begins to look less like a thing and more like a pattern traced across change. That can feel exhilarating. It can also feel like erosion. If the present is not globally privileged, then why does this moment matter so much? If the future is not coming into existence in the way it feels, then what becomes of hope? If the past is not annihilated in the simple sense, what becomes of loss? If time does not fundamentally flow, what exactly is aging? What, precisely, are we losing? These are not trivial anxieties. They are the existential aftershocks of taking physics seriously. But they may not lead where fear first expects. A less fundamental time does not necessarily mean nothing matters. It may mean mattering becomes more relational and more local. The importance of a moment may lie not in its place on a cosmic conveyor belt, but in the structure of experience, memory, and relation that obtains there. Hope may remain meaningful because uncertainty remains meaningful from within our perspective. Loss may remain real because access, interaction, and lived continuity are real even if the metaphysics of passage is revised. This is a difficult maturity. We want the universe to validate our feelings directly. We want, now, to be cosmically special. Because it feels special. We want becoming to be universal because change hurts and delights us. Physics refuses that consolation. It says, in effect, your experience is real, but it is local. Your temporal life is not the measure of the whole. That can sound demeaning. In another register, it is also beautiful. Because it means the universe is larger than the interface through which you encounter it. It means your life is not cheapened by being perspectival, it is made precise. You are a local center of records, anticipation, and change within a world whose deepest structure is stranger than the surface story consciousness tells itself. There is tenderness in that, if you can bear it. The present matters because you are here. Memory matters because records are real. Future matters because action still branches through uncertainty from your standpoint. Flow matters because organisms and minds live in flow-like ways even if the universe, at depth, Does not. What physics removes is not value. It removes narcissism. It removes the assumption that reality must resemble the form in which one primate species experiences it. And perhaps that is why time becomes such a spiritual subject once physics touches it. It is not merely about clocks or cosmology. It is about humility before a world that refuses to be organized around the categories by which consciousness first knows it. We do not get to keep the naive picture. But perhaps we get something better. A more exact wonder. A harsher tenderness. A sense that the world is not less real for being stranger, only less centered on our inherited intuitions. And that brings us to the last step. If time may be an illusion, what kind of illusion is it? And what, finally, should we mean by that word without insulting either science or experience? Let us gather the pieces slowly. The ordinary picture of time says this: the universe moves through a shared present. The future does not yet exist. The past is gone. Time flows uniformly everywhere, and clocks reveal that flow. Causality follows the flow. Memory follows the flow. Experience follows the flow. The whole cosmos advances together from one moment to the next. Modern physics has not been kind to that picture. Relativity killed universal simultaneity. There is no single observer independent now spanning the universe. Time dilation showed that different observers do not share one master clock. Duration depends on motion, gravity, and path through spacetime. Spacetime geometry then tempted us toward the block universe intuition, where reality is less a succession of universal snapshots and more a structured whole. Whether or not one embraces that view completely, the old moving present is no longer written plainly into the laws. Thermodynamics taught us that the direction of time may arise not from a fundamental arrow in the deepest equations, but from entropy and from the astonishingly special low-entropy condition of the early universe. The asymmetry we live by may be cosmological and statistical, not primitive. Memory showed us why the past feels different. The present contains records of past states. Conscious systems are record-making and record-using systems. Psychological time rides on. Physical asymmetry. Causality remained real, but its arrow began to look less like a metaphysical decree and more like lawful dependence interpreted from inside a world of records, entropy, light cones, and local interventions. Quantum mechanics preserve time in some equations while destabilizing it elsewhere. Measurement, decoherence, and temporal order became more subtle than classical intuition allows. The deeper we looked, the less obvious it became that the world is built from definite, sequential happenings in the simple sense consciousness prefers. Then quantum gravity raised the stakes. In some of our most serious frontier formulations, time threatens to disappear from the most fundamental description or to appear only relationally, approximately, or emergently. Put all that together and the conclusion is not that time is fake. It is that ordinary time is not fundamental in the way experience suggests. That is the crucial distinction. If time is an illusion, it is the kind of illusion a rainbow is, dependent on structure and perspective. But not therefore unreal. It is the kind of illusion solidity is, emergent from deeper interactions but indispensable at our scale. It is the kind of illusion a melody is, not present as a single object in any one note, yet real in the relation among them. Flow may be real for beings like us because we are beings made of records, expectation, entropy, and limited perspective. The present may be real as a local condition of consciousness and interaction without being a global property of the cosmos. Temporal direction may be real in thermodynamic, psychological, and causal practice without being etched into the deepest equations. In the most naive way, This is the deep unsettling truth. Physics has not abolished time. It has provincialized it. It has made time less universal, less absolute, less obviously fundamental, less aligned with human intuition than we once believed. It has not proven that nothing happens. It has shown that happening may belong to a more local and emergent layer of reality than common sense imagined. That is a colder, more difficult universe. But also, perhaps, a more beautiful one. Because it means reality exceeds the interface through which we first meet it. It means the categories that feel primitive to us, now, flow, before, after, may be how the world becomes livable to minds rather than how the world is in its deepest architecture. There is something haunting in that. The universe may not move through time the way minds move through experience. The present may be a feature of perspective rather than a global property of reality. Time may be less a river than a bookkeeping of change. And yet from within that bookkeeping, lives happen. Love happens. Regret happens. Discovery happens. Music happens. Death happens. Meaning happens. The fact that these may not be written into a universal flowing present does not cheapen them. It places them. It tells us where they belong, not in a simple cosmic conveyor belt, but in the rich local order of an emergent world where observers, records, and change come together long enough to call something a life. So why might time be the biggest illusion in physics? Because no other concept feels more obvious and survives the journey into modern law less intact. Matter turned out not to be solid. Space turned out not to be empty. And time turned out not to be one. That is the final inversion. The thing we trusted most may have been the roughest sketch. Not wrong enough to stop living by it. Wrong enough that the universe, when described carefully, no longer resembles the story consciousness first told itself. And perhaps that is the most honest ending available. Not that time is unreal. Not that physics has solved the mystery. Not that the flow you feel is meaningless. Only this. The universe is under no obligation to contain the kind of time human beings find intuitive. It may contain something deeper from which ordinary time emerges. And if that is true, then the greatest illusion in physics is not that time exists. It is that we ever thought we understood what it was.